Hi, today we are going to look at the quotient rule. Last set of notes we looked at the product rule. So quotient rule, just like our product rule, involves two functions. So if we have two functions, one function that's f of x and one that's g of x, now we could call them things other than f of x and g of x. However, for the sake of laying our rule out, we're going to refer to our first function of f as f of x, which will be our function in our numerator, and our second function being g of x will be in our numerator. So if both our functions are differentiable, so both f of x and g of x are differentiable at a particular x value, then f of x divided by g of x, or f divided by g, is differentiable. And to get our derivative of it, it is equal to the derivative of our numerator times our denominator minus our numerator times the derivative of the denominator, all divided by our denominator squared. So we'll do some examples to utilize this. So we want to find the derivative of y equals 1 over x cubed over 1 plus x to the power of 4. So we know y prime will be d over dx of 1 minus x cubed over 1 plus x to the power of 4. Now, like I mentioned on that previous rule, if we're taking the derivative of this, it's going to be the derivative of the numerator, so d over dx of 1 minus x cubed times our function that's in our denominator, so times 1 plus x to the power of 4, minus our numerator, so 1 minus x cubed, times the derivative of our denominator, which in this case was 1 plus x to the power of 4. And then that's all over our denominator squared. Okay, so we'll start by taking these derivatives. So the derivative of 1 minus x cubed is negative 3x squared. And then that's multiplying by 1 plus x to the power of 4. And then we have minus 1 minus x cubed times the derivative of 1 plus x to the power of 4. So that would be times 4x cubed. And then that's all over 1 plus x to the power of 4 squared. So we'll start multiplying out the terms in our numerator. So we have negative 3x squared times 1, so negative 3x squared. Then negative 3x squared times x to the power of 4 is negative 3x to the power of 6. And then we have 1 times 4x cubed, but we have this negative 1 in front, so that's minus 4x cubed. And then we have negative x cubed times 4x cubed, so that'd be negative 4x to the 6, but we have this negative in front, so that becomes plus 4x to the power of 6. And that is all over 1 plus x to the power of 4 squared. Okay, so we will combine like terms. So we've got this one that's x to the power 6 as well as this one that's x to the power 6. So negative 3 plus 4 would be 1. So that's just x to the power 6. And then we've got one that is cubed. So we've got minus 4x cubed. And then minus 3x squared over 1 plus x to the power 4 squared. Now, if we want, we can simplify this a bit because essentially we could factor an x squared of our numerator. So we could say this is x squared times x to the 4 minus 4x minus 3 over 1 plus x to the power 4 squared. Now from this, we know that we probably won't have a factor. If we were able to factor this, I'll cancel out with this. So we probably leave it at this point. In some cases, you may end up with something in your numerator that can cancel out with one of these in your denominator. Okay, next example, we want to find the derivative of y equals the square root of x over 1 plus 2x. So we know y prime would be d over dx of root x over 1 plus 2x. So that would be the derivative of our numerator. So d over dx of square root of x times our denominator, so 1 plus 2x, minus our numerator of square root of x times the derivative of our denominator, which was 1 plus 2x, over our denominator squared. Okay, so the derivative of the square root of x is 1 over 2 root x, and then that's being multiplied by 1 plus 2x, and then we have minus the square root of x times the derivative of 1 plus 2x, so times 2, divided by 1 plus 2x squared. Okay, so we'll multiply these out. So we've got y equals 1 plus 2x over 2 root x minus 2 root x over 1 plus 2x squared. Now we're not done because in math we don't like to have fractions nested inside other fractions. So we want to get rid of this fraction here. So to do that, I'm going to multiply the numerator and denominator of this larger fraction by 2 root x. Now, when we multiply this first term by 2 root x, this is just going to cancel with this, which gives us 1 plus 2x. When we multiply the second term, that's going to be 2 times 2, so 4, so minus 4. And then square root of x times square root of x is x. So we've got 1 plus 2x minus 4x as our numerator. In our denominator, we'll just move this in front of this term. So we've got 2 root x times 1 plus 2x squared. So that gives us y prime is equal to 1 minus 2x over 2 root x times 1 plus 2x squared. Okay, so we're going to review what a normal line is because sometimes our questions will ask us not to find our tangent line, but to find our normal line. So we know our tangent line gives us our slope at a particular point. Our normal line is a line that's perpendicular to our tangent line at that point. So for example, find the normal line to the curve y equals 5 over x squared plus 0.5 at x equals 2. Now, this purple line is our curve y equals 5 over x squared plus 0.5, which would make this orange line our tangent line. We can tell it's tangent because it has the same slope at that location, and that therefore makes this one our normal line because it is at 90 degrees to our tangent. Now we want to find the normal line to this curve at x equals 2. So first thing I would do is find the slope of our tangent line because the slope of our normal line is the negative reciprocal of our slope of our tangent. So we know y prime is d over dx of 5 over x squared plus 0.5. So y prime is equal to a derivative of our numerator, so d over dx of 5 times our denominator, which is x squared plus 0.5 minus our numerator of 5 times the derivative of our denominator. So d over dx of x squared plus 0.5 divided by our denominator squared. So x squared plus 0.5 squared. So if the derivative of 5 is just 0, so when we have 0 times x squared plus 0.5, essentially this term cancels out because 0 times anything is 0. And then we have minus 5 times the derivative of x squared plus 0.5. So that would just be 2x. And then that is all over x squared plus 0.5, and that's squared. So we have y prime is equal to negative 10 over x squared plus 0.5 squared. Okay, so if we want to find y prime of, or our slope of y at 2, that's y prime of 2, which would be negative 10. over 2 squared plus 0.5 squared. So this gives us, or sorry, I forgot an x when I copied this down here. So negative 5 times 2, so that should have an x there, an x here, which gets replaced with our 2. So that gives us negative 20 over, calculating this out, gives us 81 over 4. So this gives us negative 80 over 81 as our slope of this orange line. So that'd be our slope of our tangent. Now, if the slope of a normal is a negative reciprocal of that, so we can say, therefore, slope of the normal is 81 over 80. So it's reciprocal and it's the opposite sign. Now, we know our equation for a line is y minus y1 equals m times x minus x1. Now, currently, we know our m, our x1, but we don't know y1. So we will have to solve for that. So our original function was y is equal to 5 over x squared plus 0.5. So if we have a y value of, or y that we're solving for when x is 2, that's 5 over 2 squared plus 0.5, which gives us 10 over 9. So we've got y minus 10 over 9 equals 81 over 80 times x minus that x position of 2.